Today's lesson is going to be on free body diagrams. Free body diagrams are basically force diagrams. They're going to be used to represent the picture of forces that are going to be involved in a picture. We learned in a previous lesson that a force is just simply a push or a pull, and it can be caused by just about anything, whether in contact or not in contact. And today we're just going to look at a couple of these different forces and what they are. Our first of our generic category of forces is the force of gravity. The definition of gravity is basically an attractive force that would occur between any two objects. And those two objects can be as small or as big as you want them to be. Here on Earth, the Earth is always a very massive object, and it's going to always pull on other objects. So as you see in our diagram over here, the force of gravity is actually going to always be pointing down because the Earth is always going to be overwhelmingly stronger than the rest. And its symbol will be Fg when we put it into a picture. And the Fg doesn't mean a whole lot other than when we put it in the equation or keeping track of different forces, it's nice to know what it was. Our second force is the force of tension. And tension is a force that's going to be found in any kind of pulled rope or chain, and it's always going to pull away from the object. So as we see here, Spider-Man is being pulled by a tension from his web, and it's pulling away from him. If the diagram was looking at the building that Spider-Man is pulling on, the tension would have pulled away from the building, but the object in question here would have been Spider-Man, and we know that tension always pulls away. It's kind of silly to think about trying to push something with a rope because ropes don't push, they pull. And the symbol for tension will always be Ft. A third type of force that we have here is also known as friction. Friction is a contact force that happens when two objects try to slide past one another. As we see in this picture, the lawnmower is trying to slide across the ground, and friction is going to try to stop that from happening. So we have the force of friction opposing the way that you're moving. And its symbol, you guessed it, is Ff because friction begins with an F. The normal force is yet another force, and normal force is not a different type of force. It's not different than the weird force. It's just a normal force, meaning it's perpendicular to some kind of surface that you're on. Typically, it's going to be pointing up because you're normally going to be dealing with being in the on the ground, so the ground's normally flat. But if you're on a hill, it would point perpendicular out of the hill too, and its symbol will be Fn, and it's always, again, going to be perpendicular to the way that you are, to the surface that you're on. We also have a force that will happen when you're underwater or in a fluid, or if you're really a particular light material in the air. That's going to be known as buoyancy. Buoyancy is a force that's caused by a displaced fluid. So this tennis ball that we see right here has displaced some of the water, and that water, trying to get back to its spot, is actually pushing the ball back up, and as it pushes the ball up, the ball would actually begin to accelerate up until it hit the surface. And this is going to be Fb, obviously B standing for buoyancy. Our final force is, if we can't put it in any of those other categories, we're going to call it the applied force, meaning we're applying it with something, just not any number or name that we know of. So we'll call it a contact force, and it can be produced by anything. The F will be any symbol. For example, we might call this Fa, as it says here, but we might also call it Fk because it was a kicked force. Now, just a quick disclaimer, that force is actually not being applied to the ball anymore. It was only being applied when it was on Ronaldo's foot. Once it left his foot, it is no longer being applied by his foot, so now gravity takes over. But we don't need to worry about that too much. It was just the push that was created by Ronaldo's foot created an applied force. Okay, from this point, we're going to take a look at a couple YouTube clips, and we're going to apply these diagrams, and we'll show you how you do them in a problem. So in this scene that we're going to see here, Vicky is going to throw Timmy, and he's going to get stuck in the air. Okay, in this particular diagram, we now see Timmy is hanging from a cane, and we're going to add the forces in as we need to. First, we should be aware that gravity is going to be acting on Timmy, as is any object that's here on Earth, so Fg will point down. And we must say, okay, well, why is Timmy hanging in the air? Gravity, if gravity is the only force acting, he should begin falling to the earth, so something must be holding him up, and that thing is called tension, so we're marking out an Ft here. So the Ft and the Fg should be about the same size if he's not going to accelerate either way, according to Newton's second law. So what we see is we have these two forces. Now we look around and see if there's anything else. We don't see any friction going on. He's not sliding. We don't see any buoyancy because he's not underwater. We don't see any of those other forces. These seem to be the only two. So this diagram would be considered completed without adding the actual net force in, which we'll do on a later lesson. Okay, in our next clip, we're going to see an airplane landing, so we're going to use this to do our free body diagram. as we see the airplane is starting to land. Now, as it lands, you may be aware when you're on an airplane, you hear that big roaring sound, and that roaring sound is actually the engines going in reverse trying to stop the airplane. So we are seeing it as it's landing right now. We're going to pause it right here. And as we pause it, we're going to now do our free body diagram for the airplane. Now, we should be aware, like always, that gravity is acting on the airplane by trying to push it down. So we're going to mark that out as FG. We also know that if FG was the only force, that this would go through the ground, and if you're an airplane passenger, you definitely don't want to do that. So something must be holding you up, and that would have to be our normal force. Okay, and that should also be the same size as gravity, because if it's not, again, we would be accelerating up or down, and when you're landing an airplane, you're just going horizontal. Now, again, we also said that the airplane engines are now in reverse, trying to stop the plane in order to keep it from just crashing through whatever's at the end of the runway. So we will draw an F applied because it doesn't have a real name here. But we also know that the wheels are going to encounter some friction too, and that friction is also going to try to slow the plane down, so friction will be added. What you will notice here is that we did not draw any forces. In fact, if I use a different color ink here, I could actually show you that the plane is still heading forward, but the free body diagram is designed to show only the forces, not the way the airplane is moving. So the green arrows are actually the arrows that you would worry about. The red arrow is the way that it is moving. A free body diagram does not need to depict the way you're going. So overall, there is a backwards force, which is important because that backward force's job is to stop the airplane from going forward. Okay, hopefully you learned a little in this lesson on free body diagrams. Please make sure that you copy the notes from our website, and we will see you in class.